You can use data in Android apps in a number of different ways. The Android SDK includes an implementation of the SQLite relational database engine, and you can also store data in XML and JSON files. For this course, though, I'm going to keep things very simple. In this project, named Collections, I've created a couple of classes that I'm going to use to manage a set of data. First, there's a data item class named Course. This class has 4 private fields, an integer, 2 strings, and a double value. There's a constructor method that lets me create an instance of the class easily, and then there are accessor methods, getter methods, that return the individual values. I've also created a new class named Data Provider. This class declares a list of course objects. It's a static field. It's declared as private and then made accessible to the rest of the app through a public method named getData. Starting at line 14, there's a static initializer that adds data to the list. So, whenever you access any static object of this class, that'll trigger the static initializer and the data will be added. In this project's main activity class, I'm using a layout, activity main, which has just 3 elements to it. There's an image view displaying the app icon, a text view displaying the string course catalog, and another text view with an ID of TV course list. My goal in this demonstration is to get access to that data and then create a long string that I can display in this activity. I'll do all that work in the main activity class. I'll start in the onCreate method. I need access to the data, and I need to be able to address it for the duration of this method. So I'll declare an instance of the Java list interface. And I'll set the type of data that it contains to my class, course. I'll name the variable data, and I'll get it by calling dataprovider.getData. When I call the getData method, that'll be the first access of that static object. That'll trigger the static initializer, which adds the data to the list, and now I have a reference to the data I need. The next step is to loop through the data. I'll create a Java iterator. Once again, the generic data type will be course, and I'll name this iterator. And I'll get that reference with data.iterator. Next, I need a place to store strings that I'll be collecting from the list. I'll use the Java String Builder class. I'll name it Builder, and I'll instantiate it with the noArguments constructor for that class. Now I'm ready to loop through the list. I'll use a while loop, and I'll set the condition to iterator.hasNext. This bit of code is the same as in any Java application. Now, each time through the loop, I'll get a reference to the current course, with a variable typed as course that I'll name course, and I'll get its reference with iterator.next. And then I'll append some strings to the string builder object. I'll call builder.append, and I'll pass in course.getTitle. And then I'll append again, and I'll append a line feed. You could break up this code like this to make it a little bit more readable. So now, each time through the loop, I will have appended a course title and a line feed. When the while loop is complete, I'll have a long string that I can display, and I'll display it with that text view object, which has an ID of TV course list. I'll declare a text view, and I'll name it TV, and I'll call findViewById and pass in r.id.tvCourseList. And I'll make sure to cast the return value from findViewById as the text view class. And then I'll display the text with tv.setText, and I'll pass in builder.toString. So now I've retrieved the data, I've created a string builder object to contain data I want to display, I've looped through the data and put together the string I want to display, and I'm displaying it in the text view object. I'm running a virtual device that's running on Android 5, so I'll run the app, and when prompted, I'll choose the device. And there's the result. I'm displaying the titles of all of the courses. Now, this isn't particularly interactive. It's very static. I'm just displaying text, and I can't get to the details of each of the courses. So in the next set of videos, I'll describe how to use elements of the Android SDK to create an interactive presentation of this list of data that lets the user choose data and see the details. In order to display a list in an Android app, the SDK provides a couple of different components, one named List View and another named List Activity. I'll focus on the List View component, which can be used regardless of which version of Android you're programming for. The List Activity is used more commonly in a fragments-based application. I'm starting in a project named List View, which has the code I previously created to retrieve data and display some of the data in a text view. I'm starting in the main activity class, and I'm going to comment everything out except for the line of code that retrieves the data. Then I'll go to my layout file, activitymain.xml, and I'll comment out the text view component that's displaying that data. In both cases, I've gone into the file, selected the text I want to comment out, and then pressed Control/ in Windows or Command/ on Mac. Now in the layout file, I'll add a text view component. I'll go to Design Mode, and then down to the Containers section in the palette, and I'll look for the List View, and I'll drag it into place and drop it right below the RA graphic. Then I'll go into Text View. I'll change the settings of the list view that was generated as follows. I'll reset both the width and the height to match parent, so that the list view will expand to fill all available space. I'll change the ID of the list view component to this string, @Android:ID/list. This is a resource ID that's defined in the Android SDK and is used by most list views and is required for list views that are a part of a list activity. Then I'll make sure that my layout below setting is set to image logo. So that's where the top of the list view will be. And then I'll also add a top margin. I'll type margin top and choose layout margin top and set it to 10 dp. So now my list view will be aligned to the start of the screen, that's either the left or the right, and it'll be right below the image logo, and it'll fill all available remaining space. I'll look at it now in Design View, and I'll see that Design View shows me a mock-up of what the list might look like. The next step is to add some code in the main activity class, and I'll place it here after the code where I'm retrieving the data. In order to pass data to a list view, you use a class named ArrayAdapter. ArrayAdapter takes generic typing, so I'll pass in the kind of data it's going to contain. I'll pass in my course class, and I'll name the object CourseArrayAdapter. Then I'll instantiate it. The ArrayAdapter class has a number of different method signatures you can use. I'm going to use the third signature that's listed. It requires a context, which I'll set to this, and then a layout resource. The layout resource is a layout file that describes how each list item is going to be displayed. I'm going to start with a layout that's provided in the Android SDK that displays a simple string. I'll pass in android.r.layout.simplelistItem1. Then I'll pass in the third required parameter, and that's my collection of objects. And I'll pass in data. So now I have an ArrayAdapter object. Next, I need a reference to my list view. I'll declare a list view object, which I'll name list view, and I'll get its reference with findViewById. And here's the expression for that list ID that's built into Android. It starts with Android, then r.id.list. I'll be sure to cast the return value as list view. Then I'll connect the adapter and the list view together with this code. ListView.setAdapter, and I'll pass in course array adapter. So you're creating the adapter object and wrapping it around the data, and also indicating what template you want to use to display the data in each list item. Then you're getting your reference to the list view object, and you're passing the adapter to the list view with this setAdapter method. And I'll run the code. When the app appears, you see something unexpected. I'm passing in an array adapter containing course objects. And instead of seeing actual data, I'm seeing the hash code of the course object. And this tells me that the list item is looking for a string. So to fix this display, I'll get out of the app on the device and go back to Android Studio. And I'll go to the class that defines the objects that are being passed in, the course class. And I'll declare a toString method. This overrides the standard toString method that's a part of all Java classes. And I'll return the course title. Now you could add more to this. For example, you might concatenate to the title the course credits. But I'll keep this very simple, just returning the title, and I'll run the app again. And this time when the app runs, I see the actual course titles. And because I'm running a list view, I can scroll up and down, and I can click on the course titles to select them. At this point, nothing's happening when I select them, but in the next video, I'll show you how to react to the event that's dispatched when the user touches an item in the list to select it. Once you've added a list view component to your app, you can listen for events that are dispatched when the user selects items from the list. When the user touches an item in the list, that dispatches an event, and you can listen for the event and react to it. I'm working in a project now called List Events, and this continues from where the last project left off. It already has the list view and the array adapter to pass the data to the list view. And I'll add code in the onCreate method after all the existing code. I'll call ListView.setOnItemClickListener. Notice there's also an onClickListener method and one called OnItemLongClickListener. We're using this one, setOnItemClickListener, and it expects an object as a parameter that's an implementation of the OnItemClickListener interface. I'll start with new, and then OnItemClickListener, and Android Studio fills in the method stub for me. When the user selects an item, I'll be executing this method, OnItemClick. I'll receive a few parameters: an adapter view object named the parent, a view, an integer value called position, and a long value called ID. The only value I'm really interested in right now is the position. This tells me which data object was selected in my original data list. To get to that data, I'll need to address it from this code. To do that, I'm going to split this line of code at line 27 into two parts, a declaration and an assignment. You can do that easily in Android Studio by placing your cursor somewhere in the line of code and then using an intention action, pressing Alt or Option and the Enter or Return key, and then choose Split into Declaration and Assignment. Then I'll cut and paste the declaration, placing it up here as a field of the class, and I'll make it protected. So now, when I reference the data, I'm making it persist for the lifetime of the main activity. Now I'll go back to OnItemClick. Within the method, I'll declare a course variable. I'll name it course, and I'll get its reference by referencing data, and I'll call the get method, and I'll pass in the position parameter. So now I know which course record the user selected. And then I'll pass that object to a new method that I'll create here. I'll type the name of the new method, display detail, and I'll pass in the course object. And then when I see the little light bulb icon appear, I'll use an intention action and create the new method. And I'll make sure that I'm creating it as a member of the main activity class. Here's the new method. And here I'll use logcat to trace which object or which course was selected. I'll type log.d I'll pass in the name of the current activity as the log tag, and then I'll start with some text, displaying course, and then I'll output the title with course.getTitle. I'll make sure that I've imported the log class, and now I'm ready to do a test. I'll run the app. When the app appears, my logcat view will show up down here. I'll make sure that it's cleared, and then I'll come back to the device and I'll click to select an item. Now, if you don't see anything, go to the logcat view and set it to no filters, and you should see all the messages coming through. Then click into the text box and type in a string to search for, main activity. I'll right-click and clear all, then switch back to the device, and now I'll select an item from the list. And each time I select an item, I'll see a new message appear in the logcat view. And this confirms that my code is working. I'm still able to scroll up and down and choose courses, and now I'm ready for the next step, displaying the details of the course in another activity, and I'll show how to do that in the next video. So far in my app, I've added a list view component, and I'm displaying the data. And when the user selects an item from the list, I'm tracking that with logcat. But I want the user instead to go to a detail activity and see the details of the course that they selected. I'm working in a new version of the project named Display Detail that picks up where the last one left off. In this project, I already have a detail activity class, and it has a layout that displays the course's details, with text views for the title and the description, and an image view to show the associated graphic. I'll go to the main activity class, to my display detail method, and I'm going to delete the code that's outputting a message to logcat, and I'll instead create an instance of the intent class. I'll instantiate it with the intent class's constructor method, and I'll pass in a reference to the current activity and then the class for the activity I want to open. That's detailActivity.class. Next, I'll pass the course's title as an extra. I've done this kind of code previously in this course. I'll call intent.putExtra, and I need a label to identify the extra value. I've declared a couple of constants at the top of this class named course title and detail request code. I'll label this extra as course title and pass in course.getTitle. Then I'll call start activity for result. I'll pass in the intent object and the request code. And once again, I'll use the constant that I already declared, detail request code. The detail activity class already has code that I created earlier in this course. It retrieves the course title from the intent, then it gets a reference to the text view, and then it displays that string in the text view. I'll run the app, and now when I choose an item from the list, I go to that secondary activity, and I see the title of the selected course. Now I'll add some more code to display the course description. I'll go back to the main activity class, and first I'll need an additional constant. Now I'm just going to be duplicating and modifying existing code. Android Studio lets you duplicate lines of code with Control-D on Windows and Command-D on Mac. I'll duplicate this line of code. I'll change the new constant to course DESC for description, and I'll change the matching string to course DESC. Then I'll go to my display detail method, and I'll duplicate the line of code where I'm putting the extra, and I'll change the constant for the label of the value, and I'll change the value that I'm passing in. In the activity detail, I already have a text view control with an ID of TV description, and that's the control I'll use to display this longer bit of text. I'll go to the detail activity. I'll select these 3 lines of code and duplicate them. And then I'll go through that duplicated code, and everywhere where I'm referencing title, I'll change to description, or DESC. Because I'm using this string for the first time, I'll need to declare it here. And now I'll run the code again. And now when I select an item from the list, I see both the title and the description. And I'll test it on a couple of different courses. So that's the process. For each value that you want to pass through, create a constant in the main activity, make sure it's public so you can reference it from both the main activity and the secondary activity, pass the value as an extra, and then in the secondary activity, retrieve the value using that same constant to identify it and display the value with either a text view or some other appropriate visual component. My app currently displays courses in a list, displaying just the course title. But you can customize this appearance by creating your own custom layouts and your own array adapters. I'll show you how to do this in the project Custom List Item. The first step is to create a layout that shows how you want to display each item in the list. I'll go to the Layout folder under Resources, and I'll right-click and choose New, Layout Resource File. And I'll name this Course_Item. I'll change the root element to Relative Layout. Then I'll click OK, and that creates my new empty layout file. It starts with a relative layout element at the root, and I'm going to reformat this to make it a little bit more readable. I'm going to add a little bit of padding all around the layout so that each list item is separated from the other items by just a little bit. Then I'm going to add an image component and a text view to display the image for each course and the course title. I'll go to Design Mode, and I'll drag in an image view component and place it in the top left corner of the new layout. Then I'll go back to Text Mode. I'll change both the width and the height of the new image view to 50 dp. The actual image sizes will be a bit larger, but this will force the images down to the proper size when seen by the user. I'll set the ID of the image view to Image Course, and I'll delete any other attributes that were generated when I placed the image view in the layout. Next, I'll add a text view component, and I'll do all this in text. I'll add the text view, and when prompted for the width and the height, I'll set them both to wrap content. Next, I'll set an ID, and as always, I'll start with @+ID/, and I'll set this to TV title. Next, I'll place the text view right next to the image view. I'll do that with to right of, and I'll specify the ID of the image view, Image Course. You'll see a warning that if you want to support right-to-left rendering, you also need to end of. So I'll add that attribute as well, and then I'll also add a margin left setting, and this will add a little bit of space between the image view and the text view. I'll set that to 10 dp. Now I'll look at this in Design View, and I can't see much because I don't have any placeholders here, but it's good enough to get started with. I'll also set the text size for the text view to 18 dp, and that'll make the course title nice and readable. So now I'm ready to add some Java code. I'll go to the main activity class. In order to use a custom layout, you'll also need a custom array adapter. You do this by extending the array adapter class. You can create this class either in its own class file or as a member class of the main activity. If you're only going to use it here, it's best to do it in the activity itself. So I'll go down to the bottom of the activity code, and I'll declare the new class as a member after all the other methods. I'll create a class, and I'll name it Course Array Adapter. I'll add the extends keyword, and I'll extend Array Adapter. And I'll set the items that the Array Adapter manages to my data type, course. You'll see an error appear on the class declaration. I'll move the cursor back to the class declaration and use an intention action or quick fix. And I'm being asked to choose one of the method signatures for the superclasses constructors. I'll choose this one that passes in a context, a resource ID, and an object list. So now, as I instantiate that array adapter, I'll need to pass in these values. A couple of these values are going to be really useful, the context and the objects. So I'm going to save those references by creating fields. I'll create a context field that I'll name context, and a list of courses field that I'll name objects. Then in the constructor method, I'll save the references with this.context equals context, and this.objects equals objects. So now, as the course array adapter is created, I've saved those references. As the list is rendered on the screen, each list item will require a copy of the layout that I created. This happens through a call to a method named getView. The getView method is a part of array adapter, so I need to override it. I'll type getView, and I'll choose the getView method, and Android Studio creates the method stub for me. I'll come back to that return statement later. When getView is called, I first need to get a reference to the data object I want to render. Remember, I had saved my reference to the data objects here, and I'm also getting a position value here. So I'll use those two values, and I'll create a course object reference. I'll call objects.get, and I'll pass in the position. So now I know what data I want to render, and next I need to get the layout and turn it into a view object. I'll use a class named LayoutInflator. I'll name the object inflator, and I'll get its value by calling context.getSystemService. The getSystemService method can pass back a bunch of different kinds of services. Specifically, I'm looking for a LayoutInflator service, and I'll specify that with a constant, activity.LayoutInflatorService. Because getSystemService can pass back a bunch of different kinds of objects, I need to cast the result as LayoutInflator. Next, I'll create my view object. I'll create an instance of the view class, and I'll name it view, and I'll call inflator.inflate. And I'll pass in two arguments, the resource ID of the layout I want to use, and a view group. The view group is optional, so I'm going to be passing in null for that, but for my layout, I'll pass in the ID of the resource I created, r.layout.courseItem, and then the null value for the view group, and now I have my view. Now before I continue working on the view, I'll come down back here to the return statement, and I'll return that view object here. When getView is called, this is the view object that I'm returning. Now I need to add code to display the values from the course object. I'll start with the text view. I'll declare a reference to a text view object, and I'll name it TV. And this time, when I call findViewById, I'll call it as a member of my layout or view object. I'll call view.findViewById, and I'll pass in the ID of the text view, r.id.tvTitle. As always, I need to cast the return value, this time as a text view object. And then I'll call tv.setText, and I'll pass in the course's title with course.getTitle. Next, I need to deal with the image view object. In this project's resources folder, under Drawable, I've added one image for each of the courses. Each of the image files starts with image underscore and ends with the course number. So I have to concatenate the literal string image underscore with the numeric value to get the resource ID of the image I want. I'll start by getting reference to my image view component. I'll name it IV. Once again, I'll call view.findViewById and pass in the ID of the object. That's r.id.imageCourse, and I'll cast the return value as image view. Then I'll declare an integer that will be the resource ID of the image file in the Drawable folder. I'll name the integer res for resource, and I'll call context.getResources .getIdentifier. For the identifier, I need 3 arguments. First is the name of the file. I'll start with image underscore. Then I'll append to that the course number with course.getCourseNumber. The second argument is the type of resource, and that's just a literal string of drawable. And finally, I need to pass in the package, and I'll use this expression, context.getPackageName. And now I have the resource ID of the image I want to display, and I'll display it with iv.setImageResource, and I'll pass in the resource. And then I'm returning the view. So that's all the code for my override of the getView method. Let's take another look at it. First I get the course object, then I inflate the layout file and create a view. Then I pass the data to the individual objects that I want to use to display the data, and I return the view object. I made a mistake right here where I called setImageDrawable, and that should have been setImageResource. So now that code is all correct. My array adapter is finished, and now I just have to make a little change at the top here to use the array adapter. Here, I'm instantiating my array adapter by calling the constructor for the superclass. I'm going to change that to call CourseArrayAdapter, my new subclass. Just like the original constructor, there are 3 arguments here, and I'm going to pass in a value of 0 for the resource ID. That value won't be used, but I will be using the context represented by this and the data. And now I'm ready to test. I'll run the app in the device. This is the original version of the app, displaying simple strings for each course. When the app appears again, though, it now displays my custom layout, showing both the image and the course title. Now you might find that using this app in the virtual device is a little bit slow. For this app, I strongly recommend testing it on a physical device. You'll find that it runs fairly swiftly and is very responsive. So far in this chapter, I've described how to create a list, and then how to allow the user to select an item from the list, and when they go to the detail activity, I've shown how to display the 2 text values. I've also shown how to set an image dynamically in the list itself, but right now in the detail activity, I'm still always showing the default image. One of the goals of this challenge is to update this image dynamically, using an extra that you pass from the primary activity. And then, when you click on the Register button and return to the main screen, it should show a message indicating that the user has registered. Here's what the finished app will look like. When I select an item from the list, it shows the details of that item, including the selected image. I'll go back a step, and I'll choose another item. And then when I touch the Register button, I see the message indicating that I've registered for that course. You'll find the beginning files in the main exercise files folder for this chapter, and the finished version in the solutions folder. In this challenge, the goal is to complete the RU Academy app so that the 2 activities interact together. When the user selects an item from the list on the first activity, they see all the details in the second activity. And when they touch the Register button, they go back to the first activity and let that activity know that registration has been completed. Here's how I completed the challenge. I've opened the RU Academy project from the Solutions 11_data folder. First, I added some more constants at the top of the class, one for each of the values that's represented in the course class, the data item class. Then, when the user selects an item, that executes the display detail method, and I'm putting all 4 values into the intent that's launching the activity. In the detail activities layout file, I've added a linear layout in the lower right corner. Its positioning is being controlled by align settings. The linear layout has an orientation of vertical and a gravity of end, which means that the objects within the linear layout will stay on the right side. Within the linear layout, there are 2 text views and 1 button. BTN Register is the button the user touches to go back to the first screen. In the detail activity, I've added code in the onCreate method. First of all, I'm displaying the course number and the credits with the code at lines 31 through 39. For the credits, I'm using a Java number format class so that I'm always showing the numeric value with 1 digit to the right of the decimal. Then, to display the image dynamically, I'm using code that's very similar to what I showed earlier in a custom list item. I'm taking the value that was passed in for the course number. I'm concatenating that to the prefix of image underscore to match the image names, and then I'm retrieving the matching resource ID and setting the image resource in the image view component. The rest of the code is similar to what I've shown previously. When the user touches the Register button, that executes the Register click handler method, which puts an extra string into the intent, sets the result, and finishes to return to the parent activity. And in that activity, I've once again implemented onActivityResult to receive and display the message with a toast message. So I've described all the tools you need to create this simple Android app with 2 activities that passes data back and forth between the activities and deals with a data set that's provided as part of the application.